So, if your study found statistically significant correlation between two variables, what does that mean? Since we know correlation is not causation, so if you find correlation, what could it mean? At least there are four possible interpretations that you could come to based on the observed relationship between two variables, or observed correlation between two variables. It is possible that the two variables have similar causes. So if they are correlated to a third variable, then it may be that what causes the two of them are similar. So that is why they are kind of related. Let's look at an example. Air pollution and life expectancy. Okay? If there is high level of air pollution, life expectancy may go down. But it doesn't mean it's only air pollution that leads to lower life expectancy. There's so many other variables. So finding association between these variables may mean that they are of common cause. So pollution, water pollution and all sorts of other pollution could also be responsible. So it cannot only be air pollution. So there are other additional factors or variables that may be responsible for the level of life expectancy observed. Country's annual ice cream sales and frequency of hospital admission for heat stroke. Okay, so if the weather is warm, annual ice cream sales may go up, and the number of people admitted for heat stroke may also go up. It doesn't mean that one is causing the other. Ice cream is not one. Annual ice cream sale is not causing heat stroke. So finding relationship does not necessarily mean that one causes the other. It could be that the two have common causes. Another reason why you may find relationship or correlation between two variables may be that both variables are alternative indicators of the same concept. If we look at an example of church attendance or religious event attendance and the frequency of praying, both are, if we found relationship between the two of them indicates something we could term as religiosity, how religious the person is. So they are two sides of the same coin. So at times when you find relationship, it could be that the two variables that you find relationship between them, it could be that they are alternative indicator of the same concept. Another one would be if you have the two variable. Another reason you may find correlation between two variables could be as a result of the two variables being part of one complex system. So the two variable belongs to the same system. So if we look at finding relationship between wine drinking and cinema attendance, so if you find that those who drink wine also are related to the drinking of wine is related to cinema attendance, this has to do with lifestyle. It's not because one leads to the other. It's not that wine drinking leads to cinema attendance or cinema attendance leads to wine drinking. It just means that people of certain lifestyle or certain socioeconomic status will drink wine and most probably attend cinema. So it is not that one causes the other. It is just that the two variables belong to the same complex system. Okay? Finally, if you found relationship between two variables, it may be as a result of just coincidence. it doesn't have any logical reason to it, but it's just coincidental that the two are related, fortuitous relationship. So it's difficult to explain. For example, the outcome of astrological or religious prediction and movement of the stock market. You're saying that, oh, my astrologer predicted that I'm going to win big today, and then the market also moved big. So if you look at market prediction by astrologers and you compare it to what happened in the market, if you find some relationship, it doesn't mean that actually the astrologer was able to predict the market. It's just coincidence, because if we have more data and we look at things further in a random environment, there is bound to be sometimes you see things that appear to be related because you narrow your focus to a particular period of time. If you expand your horizon and you look at more data, you begin to realize, to see that there is actually evidence that suggests that this relationship is just coincidental. It has nothing to do with real fact or the real world. So these are the four reasons at times that when you see correlation, you need to look at them carefully, because the relationship you're looking at may be based on any of these four reasons. The association you observe may be due to these four reasons. Okay? So, when do you come to conclusion that what happened here is causality? Okay? If you have a very strong relationship, when can you make inference that what you have observed is causality, one causing the other? John Stuart Mill gave us these four rules, or three rules rather, before you can make inference that something causes the other. Covariation rule, which means the two of them must be correlated. So when you do your correlation and you have a strong correlation, then you might infer that one causes the other. But that is just one. The next one will be, there must be temporal precedence rule. There must be temporal precedence, which means for X to cause Y, remember, Y is the dependent, X is the independent. For Y to be explained or caused by X, X must be before Y. The treatment must happen before the result. You cannot have the result after the treatment. So there must be temporal precedence. X must occur after Y must occur after X, not Y before X. You cannot have the result before treatment. You must have treatment before result. Okay? Then there is internal validity rule. It must not be possible to find alternative explanation for this causality. If there is an alternative explanation, then you cannot say that this causes X causes Y. So you remember covariation rule. First of all, there must be strong correlation, temporal precedence. X must come before Y if we're going to say X is the causal factor for Y. Internal validity. There must not be any other alternative explanation for why X caused Y. If there are other alternative explanation, then we cannot say that X causes Y. So in practice, you must exercise a lot of caution when you are trying to make inference of causal linkages, because there are other confounding variables that may affect that your conclusion. So it's better to state that there is an association, hold on to that until you can find more evidence to suggest causation. So in order to say for sure that there is causation, you must look at the confounding variables and control for their effect before you can actually come to the conclusion that X causes Y. So that brings us to the end of research design. So make sure you go through the tests and the quizzes and additional materials provided so that you can get an in-depth understanding of the concepts that have been presented. It is important that you do a little bit of reading to really cement your understanding of this concept. Bye for now.